So sodium will rush into the neuron. So how would our graph look if we all of a sudden have an influx of positive ions flowing into the neuron? It would spike up. So if we take a look back about our graph over here, notice that you get a sudden increase. So I'm going to use red to kind of like highlight that increase. So it'll increase, the voltage will increase to about around positive 30 millivolts. Sometimes a little more, sometimes a little less. Something that you guys might have missed is notice on the graph there is this horizontal line right here. So it's a dashed line that kind of faded. This is the threshold line. For muscles, the threshold had to do with the minimum amount of acetylcholine. If a muscle didn't get enough acetylcholine, what happened?
It doesn't move.
Nothing. No movement, no contraction. If it got just enough right to the threshold, the whole muscle fiber contracts, right? Neurons are kind of similar. If they don't get enough sodium in, you get no nerve impulse. So you know how sometimes you're passing up papers and then like the crossword puzzle and then you're like tapping the person's shoulder? Hey, take my paper. And you're like, what's her name? What's her name? You know her name? Do you know her name? And you're like asking other people like what that person's name is and you're like tapping them and they don't feel it? And like for some reason you're like, take my paper. Oh my God, right? And they don't feel it. Sometimes, for some reason, when the stimulus is not strong enough, sodium will start going in, but not enough sodium will go in. So if not enough sodium goes in, it doesn't hit that threshold, that nerve impulse won't happen. That means it won't register. You won't feel it, you won't hear it, okay? Like, you know how some people, they're like, it's cold in here. And some people are like, no, it's fine. Like, it doesn't feel cold to me. Some people have a different threshold, right, for temperature. Okay, so he has a pretty low threshold. He felt it right away, right? Okay, so that threshold is at negative 55 millivolts. So if that stimulus is strong enough sodium rushes in, and the voltage goes up to negative 55, then you get a whole nerve impulse. That's when the stimulus will be registered. So I'm going to add down here, if threshold is reached, and threshold is approximately negative 55 millivolts, then we say that we have an action potential. If the sodium channels at node number 1 over here reaches threshold, it's kind of cool because as soon as that one reaches threshold, it will actually cause the sodium channels at node number 2 to also open up and start adding sodium into the cell. So it's a domino effect. If the sodium channels here add up to the threshold, that'll cause the sodium channels over here to open. If the sodium over here reaches threshold, then the sodium channels at node 3 will open. Okay, so I'm going to add that down here. This will lead to a sodium channel at node number 2 to open up. If sodium channel at node number 2 opens up, that means sodium can flow in at node number 2 now. So if the sodium channel at node number 2 are opening and the sodium's done flowing in at node number 1, the sodium channel over here is going to shut. So that's actually phase number 3. In the picture, it's not very clear, so you might want to add 2 lines right there. The sodium channels are shut in the next phase. They're closed. So no more sodium can flow in. Instead, you're going to have potassium flowing out. So I'm going to use blue to outline the potassium channels. They're going to open up, which means potassium can flow out. So the potassium is gonna flow out. All the positive charges are leaving. So if you look at step number 2, the potassium was originally hanging out with the sodium, and think of it as potassium gets claustrophobic, okay? Too many ions inside, too many people in one building. It wants to leave. So all the potassium's like, I'm out of here. I need to go get some fresh air. So all the potassium leaves the cell, which means if all the positive ions start leaving the cell, what happens to the inside of the cell now? It starts getting more negative and the outside gets more positive. So this step is called repolarization, when potassium starts flowing out of the cell. So this is when sodium channels close and potassium channels open. If potassium channel open, that means potassium will leave the cell. So therefore, the inside becomes negative again. So if we look at our graph up top, if potassium starts leaving and the inside becomes negative, what will happen to the graph? It starts to go down, okay? So if we look, okay. Notice step 3, I'm gonna use blue to try to outline the graph a little bit. Potassium's leaving, positive charge is leaving, so you become more negative, more negative, more negative, and that's step number 3, repolarization. And then the last step is returning back to resting potential. So real quick, if you compare step 1 to step 3, there are a few major differences and similarities. With your partner, come up with at least 1 or 2 similarities between these 2 phases, and then 1 or 2 differences between these 2 phases. Notice what's on the inside, what's on the outside. So see if you guys can figure out differences and similarities.
With 1 and 2, or 1 and 3, 1 and 3 is
yeah, the sodium.
they have the charge.
Or this one. Number 3 is the potassium channels are open.
1 and 3 are negative on this side.
All right, Maddie, give us a similarity. They're both positive on the outside and negative on the inside. Thank you. Janessa, give us a difference. You guys, are these 2 exactly the same as the question? No, there's something different. Just tell me one thing that's different between the 2 pictures.
Sodium goes out.
For the first one?
Yeah.
Okay, so you have more sodium on the outside. What about in the third picture? What do you have more of on the outside? Potassium. So that's your difference. You have more sodium on the outside. This one you have more potassium on the outside, which means this cell is not completely back to normal yet. That's why there's a step 4. So even though the charges are right, the ions are wrong. Okay, so we're gonna do step 4 tomorrow. If you guys wanna go ahead and start packing everything up.